My name is Kathleen Carpenter, and the first thing I want to do is to thank you for volunteering for Science Day. We're going to demonstrate the experiment about magnetic force. The purpose of this experiment is to explore magnetism. Now, there's an important warning to know up front. You will have a neodymium magnet in a box like this, and it's really important that only adults choose it, or only adults use it, because it's very powerful and the kids could cause trouble with it. So, before you get started, you want to give the kids a little background about magnetic force, which is in your handout, and about how magnetism is created. And the children have just finished working on some magnets, so they may be able to tell you something about it to start. So, the most important thing is that the neodymium magnets are very powerful, and if they get stuck together, we will not be able to separate them. So do not place them near other magnets, electronic devices, or the credit cards in your purse or wallet. So just that warning up front. So the first part of the experiment involves students exploring what items are magnetic. So you're going to have a piece of fabric, you're going to have a piece of cardboard, you're going to have some paper clips, some crushed Total cereal, and a dollar bill on the table. And you want the children to explore which of those items might be magnetic and why or why not. And so you're going to take out the magnet then and try each item and see, and this still has some stuff from the last time it was used on it. Is the fabric magnetic? No. Is the cardboard magnetic? No. Are the paper clips magnetic? And this shows you how strong this magnet is. That it will get to those paper clips even through the box and it'll stick hard. Is the dollar bill magnetic? And they're going to feel some pull on that. And you'll talk about what happens with dollar bills. And then, when I put this magnet down the cereal, I actually see some cereal that sticks on the magnet. So there's something in that cereal that's making it magnetic. So, and you want to look at you'll have a list of ingredients for Total cereal, and it'll show iron on there, and you want the kids to explore that. So what we're going to do then is take out the bag of soggy Total cereal. You want to make sure that it's really soupy and looks kind of icky. But the first thing you're going to do is put the magnet on top of the bag, and then you're going to put your other hand on top of the magnet and flip the whole thing over, and you're going to slosh and slosh around, and about 15 to 20 seconds. And the idea is to attract any of the free floating magnet iron pieces, iron particles in the cereal to the magnet. So we're going to use both hands again, and we're going to flip it over so the magnet's on top. And then what you're going to look for, and you can actually see it in there, look in the bag. There's little black, see those little black particles? And they move around. Do you see it, Rachel? Mm-hmm. That's the iron in the cereal. So there's actually little tiny, tiny flecks of iron in this cereal. And so you want to look real closely at the edge of the magnet, and if you move it around, the iron will float with it. A little tiny bit. So that's the iron. And you draw a circle, and you'll see the iron getting into a bigger and bigger clump in the bag as you move around. So you want to have the children then guess, if they have a guess about what the iron specks are, if they haven't guessed it already. And then you want to make sure that you put the neodymium magnet away, because we're done with that now, and we want to be real careful with that. So you can also share the interesting fact on the guide sheet, which talks about how you can destroy a dollar bill because dollars have magnetic ink on them, and that the neodymium magnet is so powerful it can attract pieces of iron that we can't even see. So now we're going to measure how forceful different magnets are. That's part 2 of the experiment. So each child is going to get a magnet. So pick up, which magnet do you want? That one? Okay. And then you're going to take a ruler and put it on the table. And you're going to put a paper clip at the 0 mark of the ruler. And then what you're going to very slowly do is to start, and you have to watch, you start to slide your magnet toward the paper clip. Don't move the ruler. Slide it toward, and see when you get to the point, and this magnet you got to be careful because the ruler has some metal in it too. See how close you have to get. Oh, we had to get really close. So this magnet isn't very strong. So let's put the paper clip back. Put the paper clip back. And let's use a different magnet. And slow, now so you can't touch the ruler. Someone might have to hold the ruler if your ruler has any metal in it. Keep going. See how close you have to get. To get the paper clip to come to your, so it's about the same. So then let's try the third one. And you see what's going to happen here. So then the kids can talk about how close each magnet had to get and what that might mean, and if they could say which magnet do they think is strongest, and it should be the magnet that pulls the paper clip, the furthest. And if you want to and you have time, sit down please. If you want to and you have time, you could even use the neodymium magnet here. Let's just see. Let's put our paper clip here. Remember, only the adults touch this magnet. And let's see how far we can get. The others we had to get within about 1 inch to attract the magnet. And you'll have lots of different magnets in your materials, so your results may be a little different. But here we are at the 4 mark. Let's go to the 3 mark. Let's go to the 2 mark. Let's go to the 1 mark. Oh wow, did you see it? And how it flew up there. So you can talk about which magnet seems to be stronger than the others and how much stronger this one is than any of the others. Yeah. So then the last part then is to let the kids have some fun with the magnets. So get a magnet, and you can use that one. You're going to have a collection of paper plate mazes and a collection of cars that have paper clips inside them. And so what the kids are going to do is they're going to put their car on the top of the maze, and they're going to put their magnet underneath the maze, and they're going to try to drive their car, nope, you went too fast, along, oh, and this one doesn't seem to work too well, maybe that magnet's too wimpy. There we go, and drive the car along the maze. And they can see how they can hear it. Let me use the purple one.
I need a car.
I know, but you, just a minute, I only have 1 car. Now try it. There you go. And they'll see that they can drive a car along the maze without touching the car. So you can try that too. Then at the end, if the kids want to talk about iron a little more, you can share the facts with them about how if all the iron in your body was removed, you'd still only have enough to make about 2 small nails, but how important it is and how it helps with the body to function and what happens if you don't have enough iron. So that's the magnet experiment, and we look forward to you helping us out on Science Day. Thank you.